Concrete is one of the oldest and most commonly used building materials found today. It is also the most versatile, being used for not only buildings, but for roadways, decoration, and support structures. It is also recyclable due to the fact that it can be crushed and reused for its original purpose.
Concrete has evolved into a specific recipe of water, aggregate, and Portland cement. The aggregate is commonly composed of rock, sand, or gravel. Portland cement is not a brand, but a dry powder mixture of calcium, silicon, aluminum, iron, and small amounts of other ingredients. When this cement is mixed with water and the aggregate, the end result is concrete.
Our journey starts with the ancient Egyptians in 3000 BC. They used early concrete, made of mud and straw. The Romans paved the way for many things in modern society, and using concrete in the building of the Pantheon and the mighty Colosseum, the fall of the Roman Empire saw a long decline in the use of concrete. Fast forward to 1793, when the father of civil engineering, John Smeaton, put concrete back on the map by creating hydraulic cement. Smeaton identified the compositional requirements for cement to harden without having to be dry. This single discovery is at the heart of every sea wall, canal, and bridge built since. Joseph Aspdin registered the patent for Portland cement. The genius and efficacy of Portland cement was proved when renowned civil engineer Isambard Kingdom Brunel used it to fill a breach in the famous Thames Tunnel. The first concrete house was built in 1835. The growing metropolis of London underwent a massive transformation as the complex London sewerage system was built using Portland cement. The construction involved 2.7 million cubic meters of excavated earth, 318 million bricks, and 670,000 cubic meters of concrete. The next huge leap of progress was made in 1880 with the introduction of Pudloe, the world's first ever waterproof admixture for concrete. The start of the 20th century saw rapid advancement and an increasing role for concrete in the expansion of cities, roads, and grand engineering projects. The first concrete high-rise building was constructed in 1903, and the first affordable housing project followed shortly after. The first concrete framed skyscraper was built in 1909. The stunning engineering project, the Hoover Dam, in 1913. Across the 20th century, concrete was at the heart of some of the most impressive structures the world has ever seen.
Concrete has evolved from just a building material to a decorative purpose in homes. Concrete can be stained, etched, stamped, cut, or finished into an end user's needs. Concrete is a material with a good compression strength, but often needs reinforcement for its tension strength. It is often reinforced with rebar, steel, fiberglass, or plastic. Concrete can be formed into different shapes or textures prior to the pour curing. When concrete is still wet, it is a highly alkaline product, though, and may cause burns.
Strength. Research into the increased strength of concrete was the challenge of the 1980s. In fact, when you look at development curves for concrete strength from when it started up to the present day, we've seen incremental progress based on experience gained from construction sites. A little bit of tinkering, you might say, until about the end of the 1970s. Then, at the beginning of the 1980s, we began to introduce some science into concrete, to understand how it worked, why it was resistant, what were its weak points, etc. In fact, by going deeply into this subject, we reversed the curve. We started from a very, very high point and achieved levels of strength 10 times greater than ordinary concrete. And then we came to a bit of a halt, quite simply because the construction industry did not grasp such performance. We're now able to produce concrete of 200 megapascals in strength. That's to say roughly 5 times stronger than concrete in structures 20 years ago, and in the order of 10 times stronger than the ordinary concrete used in apartment construction, for example. So a strong concrete is long-lasting, and that's why we talk of high-performance concrete rather than high strength. It's both stronger and more long-lasting than traditional concrete.
The concrete industry is a worldwide industry that is as strong as its name is. The annual consumption worldwide is between 21 and 31 billion tons a year. In the United States, it is a $31 billion industry that employs over 2 million workers a year.
The impact of emissions from a Munster concrete plant on nearby residents. About 60 people who live near the Coburn cement plant took their concerns to Parliament House. The local Labor MP Fran Logan says dust regularly covers cars and houses, causing serious health problems.
We've had examples of children with nosebleeds, with scabs up their noses, with people who have bronchial problems. We have examples of people suffering from asthma who have to be admitted to hospital.
The company has agreed to make a significant investment that will presumably reduce the dust, or part of the dust. It still leaves the issue of odour, and that's a serious issue.
The company says it will build a $24 million filter at the plant and improve environmental management.
Concrete is a strong material that does have some drawbacks. During its manufacturing, it does produce carbon dioxide. It is also vulnerable to highly acidic compounds, water, fire, and expansion. However, it replaces more harmful products used in construction and uses more abundant natural resources.
I believe that from the point of view of durability and the building's environmental impact, it's very definitely the material with the most benefits. Durability is important for 2 reasons. First of all, financially. If you have a building that deteriorates, you have to repair and maintain it, which will cost money, stop you using it, etc. Secondly, there is a reason that's more closely related to aspects of sustainable development. If a building lasts for 100 years rather than 50 years, you're not going to have the same environmental impact with this building in terms of the materials that have been used to build it. Concrete is certainly the most long-lasting material that can be made. Today we're able to guarantee life cycles of 50 years, 100 years, 120 years, even 300 years. No problem. We have the tools, we know the processes for developing the material, and we know how to work with them. It's a material that in these conditions doesn't need any maintenance, and what's more, it's 100% recyclable. I believe that from the point of view of durability and the building's environmental impact, it's very definitely the material with the most benefits.